Laws of reflection we have discussed that. We did learn about the formation of image by a plane mirror in the previous class. So I will be revising this topic once again for those who were absent. And in today's class, we'll be learning about uh, dispersion of the light. Okay, now that is something which you are going to learn today. Okay. By the way, those who were present in the previous class, you guys understood about the formation of image by a plane mirror now? Gauri, Chakrika, and Abdullah, you guys were present.
Yes, sir.
Yeah. Okay. Khadija, pay attention to this diagram here. Okay, Khadija. By the way, all of you, turn your cameras on in the class. Yes, everyone. See, in this diagram, formation of image by a plane mirror is being shown here. This M dash represents a plane mirror. The shaded lines are representing the back side of the mirror here. So let us consider this figure here, in which there is an object AB of height h. It is placed at a distance u from the mirror. So when the rays of light from this object will be falling on the mirror, so thereby the image of that object will be formed inside the mirror. It will be formed inside the mirror, and it will be appearing to form inside the mirror at a distance of v. Let's call this distance as v. Okay. So let's say that there are some incident rays that are falling on the mirror. Yes, Gauri, what are the incident rays that were falling on the mirror here?
AP.
Yeah. AP.
Then PA.
PA. No.
No.
PA is the
sorry,
reflected ray now.
BO.
BO, good. BO.
AO.
AO.
And BN.
And BN. Very good. Okay. Now, Abdullah, you will tell me what were the reflected rays. As these rays are falling on the plane mirror, which is a smooth surface, so they will be reflected back. So what are the reflected rays here? Abdullah, you there?
Yes, sir.
Tell me the reflected rays now.
Sir,
PA is the
PA is reflected ray.
Okay. Then
And PN.
P.
And
Where is PN? No, there is no such ray as PN. Khadija, you're getting it now what we are discussing right now. See what we have discussed so far, that there are some rays coming from this object. Let's suppose that there were some light is falling on this object AB, let us say. It could be coming from a tube light, let's say. So it will be reflected from the body AB here. Okay, Khadija. Right? So the reflected rays from the body of the AB, it will be falling on the plane mirror. So we will call those incoming rays of light as incident rays. Okay, because it is incoming on the plane surface here, on this plane mirror. So AP is the incident ray. Then take a look at this. AO is the incident ray. Okay. Then another ray is BO. And then you have BN. All of these are the incident rays. Yeah. Yes, Abdullah, continue.
sir, NE is also a reflected ray.
Exactly. And E is also a reflected ray. So as these rays will be reflected falling on this plane mirror, then they will get reflected. So PA is a reflected ray. Then you have this OB is the reflected ray. Okay, now then you have OC, that is also the reflected ray. Then this BN ray is falling like this, it will get reflected like ray NE. Okay. So what happens here, that as we will be extending these reflected rays backward now, when these reflected rays are extended backward into the mirror, like the dotted lines are showing that you have extended these rays backward into the mirror. So thereby a virtual image of height h will be formed here. Where these rays will be meeting, there the image formation will take place here. Getting it? So that is how the image formation takes place here. That is how the image is formed here. Got this now? Also the image that is formed, it's a virtual image. It's not an actual image that is forming there, right? An image will be of the same size as the object. Object has the height h, and so as the image that also has the height h. And image appears at the same distance behind the mirror as the object is in front. Is it actually at that distance behind the mirror, or does it appear to be at the same distance behind the mirror as the object is? You guys tell me.
It used to be.
So it's appear.
Right? It appears to be, but it is not actually at that same distance, but it appears to be at the same distance. So this is how the image formation takes place by the plane mirror. Khadija, is that clear to you?
Yes, sir.
Okay. Another special things which we have learned about, that if you're running towards the plane mirror with a certain speed, let's say 10 meter per second, 15 meter per second, or 5 meter per second, so your image will also appear to be running towards you with the same or different speed. With the same or with a different speed, yes?
Same.
With the same speed, very good. Also, we have learned about lateral inversion, like whenever an image is formed in a mirror, so the left side of the object appears to be the at the right side of right side in the image. So that is the case of the lateral inversion, and it has some applications, as we have learned that intentionally the letter ambulance is written like this in the ambulance, so that in the rear view, this is the rear view mirror. 1 minute. That here is the rear view mirror, in which the rear view mirror lateral inversion will take place, right? Lateral inversion will take place, and the letter will be spelled correctly like this. It will be viewed in this order. Okay. Further, I also told you guys about one important fact, that suppose someone is measuring has a height of 6 feet. So in order to get his full body image in a plane mirror, he at least requires the image. He at least requires the plane mirror to be half of his size. Okay, now, so to get a full body image in a plane mirror, the height of the mirror should be half of the height of the person or the object. So these were some of the important things which we have learned. Today we'll be learning about different types of images. Basically, there are two types of images. We have real image and the virtual image. We have real image and virtual image. So let us understand how they are different from each other. Okay, na? See, talking about the real image, basically an image that can be obtained on a screen, and where the rays will be actually meeting together. Okay, now that will be the case of that will be the situation in which a real image will be formed. But in the case of the virtual image, the rays will appear to be meeting together. Like take example of this one here, which we have discussed moments ago. Are the rays actually meeting behind the mirror, or they appear to be meeting behind the mirror?
They appear.
Everyone, they appear to be meeting behind the mirror now. So that is
Yes.
the fundamental difference between real and virtual images. Okay. So light rays will be actually meeting in the case of the real image. Whenever real image will be formed, a light rays will be actually meeting at a point to form a image. Consider, for example, like when you it could be the image can form via like consider this example. All of you, as a kid, you might have done this thing, like you might have projected the magnifying glass over a paper like this. Okay, and the sun's rays will be converging. See that this is the sun's rays coming from this, and it will appear to converge at a point like this. The sun's rays, it will, as it will pass via the magnifying glass, so it will converge at a point. And here the image of the sun is formed. So that bright spot that is formed on a paper now, that is actually the image of the sun. So this is the case where the rays are actually meeting at a point now. That's how the image of the sun is formed on a plain paper when you project it in the sun. Or no, please let me know.
Yes, sir.
Others are not getting it, I suppose. Yeah. So here the rays are actually meeting. So thereby, is a virtual image of the sun being formed, or the real image is formed here?
A real image.
Exactly. So a real image is formed here because the rays are actually meeting here. But in this case, a virtual image is formed here. In this case, a virtual image is formed, as the rays will be appearing to meet together. So the fundamental differences are as follows: that in the real image, rays actually meets to form a Real image. And real images, it can be captured on a screen also, or it can be focused on some screen, right? And they can be formed by different kind of mirrors. They can be formed by lenses also, right? Real images, like here you have a lens or a mirror. Magnifying glass, it has a lens now.
Yes,
Getting it,
sir.
guys? Okay. And magnifying glass, what kind of lens does it have? Later on we'll learn that there are two types of lenses. Concave lens and convex lenses are there. Okay, now concave lens and the convex lens. Getting it? Convex lens, later on we'll be learning about that. Okay, now I won't be touching that topic right now. So we are learning about the fundamental differences. So image that will be formed when the rays will be actually meeting. So in that case, a inverted image will be formed. Upside down image will be formed. An upside down image will be formed. Say for example, you will ask, sir, like how can we get a how can we like show some example? So what you guys can do now, you can get the inverted image of the candle flame. You can get the inverted image of a candle flame if you were to place a convex lens exactly in front of the candle flame. What you can do here, say for example, this is a candle, that is the flame of the candle. How many zones are there in the candle flame?
3.
Very good. So say you have placed a convex lens. What kind of lens I have placed here? It's a convex lens. Okay. So as we'll be placing a convex lens in front of this over here. So on this screen, let us say that this is a wall. Basically a screen. So it could be, let's say, a wall. So here an inverted image of the flame will be formed. It will be like this. Everyone getting it now? This is upside down, inverted images form, right? So that is one of the property of the real images, that whenever real images will be formed, so it will be an inverted image. Everyone clear with this topic?
Yes, sir.
Okay. Talking about the virtual image further. So in the case of the virtual image, the image will be generally erect. It will not be inverted. Okay, it will not be inverted. Further images, in the case of real image, it can be obtained on a screen as we have obtained this. But can you obtain your image that you are seeing in the plane mirror on a screen? Can you obtain it? Obviously, no. So since they are virtual images, hence, and the rays are not actually meeting, hence it cannot be obtained on a screen. Okay. And and this fourth point, that this we will be relearning while we'll be learning about the lens. There we will revisit this concept, that which says that the image is formed in front of a mirror and behind the lens. This is something which we'll be learning later on. Okay. Further, the real image, we can reach it. Basically meaning that you can actually see it forming on a screen. Okay, no? But in the case of virtual image, you can't actually see the formation of it on a screen. So that is the difference between the real image and the virtual image. Plus, also let me tell you that in which situation this will be formed. Okay, no? Like I mean to say that using which kind of mirrors and lenses a real image can be formed. Okay. So real images are formed by concave mirrors and convex lenses. By concave mirror and the convex lenses. That is one thing. And for the virtual image, everyone knows this. That is, yeah,
Plane mirror.
exactly. So it is formed by a plane mirror. Okay. Next, now we are going to learn about the case of multiple reflections. So many times you guys might have seen this, like multiple images will be formed. If plane mirror were to kept at certain angle, and multiple images will be formed. Okay. Also, if you keep on changing the angle, so thereby the number of images that will form will either increase or decrease. Okay, now, so that is the concept of multiple reflection, and you can calculate how many images are formed based on the angle at which the plane mirrors are inclined. How many images of this coin is formed here?
4.
4, right?
Wait.
Okay. So let us learn about this one in detail. Like basically what is the concept here? So multiple reflections, it can be obtained by placing more than one mirrors at certain angle to each other, in which reflection will take place multiple times. Like what is happening here? The incident ray from this ball is falling on the plane mirror, and it will again be reflected back from this, and the reflected ray will fall on this plane mirror, right? Then again reflection will take place from this. So reflection is taking 2 times here. Multiple time reflection is taking place. Once it took from this mirror, another reflection took from this mirror. You can understand it in the following manner. See that these are the incident rays that are falling on this mirror, right? It will get reflected, right? Now,
Yes, sir.
so this is the incident ray. Let us call that this is the plane mirror A. It's plane mirror A, and let's say that this one is plane mirror B. So this is the incident ray for the plane mirror, and this one is the reflected ray for the plane mirror A, right? But for this plane mirror, this ray will it not be the incident ray as it is falling on it now? Yes or no?
Yes,
This
sir.
ray that has got reflected from the plane mirror A, as it will be falling on the plane mirror B. So for the plane mirror B, it becomes the incident ray now, right? Again, it will get reflected back from this now, like this, let's say. So this one becomes the last ray which I have drawn. What will it be? Reflected ray now. So how many times reflection has taken place here?
2.
Yes. Okay, Khadija, what about you? How many times reflection has taken place here?
2.
Right? Chakrika, Abdullah. So that is the case of the multiple reflection. And as a result of this, multiple images are formed. So multiple reflections can be obtained when we place more than one plane mirrors inclined to each other at some angle. Okay. As a result of this, multiple reflection takes place. Multiple reflection takes place, and thereby multiple images are formed. Multiple images are formed. Hope that much should be clear. Okay. Now, this concept of multiple reflection, later on, we will learn that it has some applications. Like, you guys ever thought about this? Like, how are the people under the submarine able to look at the surface? If they're under the submarine, so how will they be able to look at which ship is going on the floating on the surface, or if they have to keep an eye on the enemy ship, so how are they supposed to look at that? So for that purpose, they have some special instrument called as periscopes, which is installed in the submarine. It is installed at different other places also, right? Or as a child, I suppose you guys might have played with this. Anyone seen this thing?
Yes, sir.
Kaleidoscope, yeah. Also in the school, it is given as a project work also, as an activity also to make this kaleidoscope. So there also multiple reflection is taking place in this kaleidoscope. In the periscope also multiple reflection takes place. But first we are going to learn about some formulas, like how, like for example, if the two plane mirrors are inclined at an angle of 90 degree, so how many images will be formed? If they're inclined at an angle of 120 degree, how many images are going to form? Isn't it? So first of all, let us learn about that, then we'll be continuing further. Okay. So there's a formula to be used here. Let me go to this slide. So we have some formula to use this. Okay, now formula to calculate the number of images formed is n equals to, and here means number of images. Okay, now n equals to 360 degree upon theta. This is called as theta. Okay, theta here is basically representing the angle. What is it representing? Yes, Chakrika? It's a symbol for it's a symbol for angle. Okay, so n is telling you the number of the angle, number of the images formed between the two plane mirrors. Okay, now say if the n comes out to be an even integer, if it comes to be an even integer, even number, right? Now, so if n is an even integer, so that the number of images that will be formed will be n minus 1. So if when you calculate the value and if n comes out to be even number, so thereby then the number of, this will be more clear once we do some questions. Okay, now so then number of images will be n minus 1, but the n could be a odd number also, no, right? So if odd integer, if it is an odd integer, then the number of images will be simply n. There will be no change in it, neither n plus 1, neither n minus 1. Let us consider an example, guys. Sorry about that. Let us consider an example that there are two plane mirrors, and let's say it is inclined at an angle of 90 degree over here. Okay, now so they are kept perpendicular to each other. So n will be calculated in the following manner. In this, n will be 360, and what is the value of theta here? 90 degree. Okay, so 360 upon 90 will be equal to how much? Yeah, quickly tell me.
40.
How much?
Sorry, 4.
Oh, 4 now. Yeah, so 4 is even or odd? It is even integer.
Even.
Exactly. So we should be subtracting 1 from it now. Getting it? So now it will be 4 minus 1 equal to 3. So hence 3 images are formed. How many images? 3 images are formed. Suppose if there's a ball kept over here, so how many images of the ball will be formed here?
3.
3, exactly. So that's it. You guys will, I suppose you guys have understood. Suppose if the answer came out to be an odd number, so you will not do anything. That will be your answer. Okay, now let us suppose if the angle between the plane mirrors were to be 120. Let us suppose another situation. $120 is a acute or obtuse angle? Yeah,
Obtuse.
obtuse. Good. So n equals to 360 upon 120, and n came out to be 3. So 3 is an odd number, so thereby the number of images will be 3. You don't have to add or subtract 1 to it. Okay. So if everyone got this, I'll be giving some questions. If there's some doubt, please let me know. Yes. Any questions?
No, sir.
Okay. Let's do some questions then. Do this question. Everyone will be putting their answers in the chat box only. Okay. Yes, very good, Chakrika. You're scoring good. No, Abdullah, that is not correct. That is not correct. You guys can take the help of this formula once again if you are forgetting it. You guys must have been to a circus. I suppose you must have been to a circus sometime. So there you might have visited a room where multiple plane mirrors would be kept at certain angles. So there you could have seen this, that your multiple images will be formed, like this one over here, like this. Okay, na? Yes, Khadija, that is correct. See, Abdullah, the thing is now, the theta given here, the angle between the two plane mirror is 40. So 360 upon 40 equals 9. So 9 is an odd integer, so thereby it will be as it is. No changes will be made in this. So 9 images will be formed. Okay, Abdullah. Okay. Now let us consider a situation that, let us, like for example, when we go to the, when we visit a saloon, like in this one, this, say that this is a saloon, for example. Saloon, or basically two plane mirrors are installed on the opposite side. Okay, now one on this side, one on the other side of the room, say. So can you count the number of images here? Let me zoom it out. Will it be easy for you to count the number of images?
No.
No. So when two plane mirrors are placed parallel to each other, so what is the angle formed between the two?
0 degree.
0 degree, exactly. Right now, so when the angle between the two plane mirror is 0 degree, so exactly, Chakrika. So infinite number of images will be formed. Got this, guys? So infinite number of images will be formed. Okay. So note down an important point here, that a special case, that when the two plane mirrors are inclined at 0 degree, or basically parallel to each other, then infinite number of images are formed. Okay. Okay, let's do this question. This question now we'll be revisiting once I would have explained about the type of curved mirrors. Okay, now. So this question we are going to do right now. Everyone read the question carefully. Read it carefully and solve it. First, you guys will try to solve it, then I will be helping. Yeah, Chikrika, we are going to do some more questions. You want to do some more questions on this one? You guys do want to do some more questions on this? On calculation of number of images?
Yes, sir.
Okay. So I will be just changing the values here. Okay, now. So see that if they are inclined at 72 degree, so then tell me the number of images formed here. The correct answer for this question is there in the option, so you guys can still answer it there. Correct, Chakrika. What if it were to be 60 degree? If it is 72 degree, tell me what will be the number of images, or if it is 60 degree. Also, let's take one more. If it is 180 degree, Chakrika, the other one is not correct. For 72, your answer is correct, but for B, it is not correct. Should I put the screenshot of the formula in the chat box? I'm going to put it there, the chat box. 1 minute. Okay, there you go. I have put the screenshot there.
The question was 60-degree, right?
Yeah, it is 60 degree.
So 360 divided by 60 would be 6, right?
Yeah, exactly. It will be 6. 6 is an even number. So what are we supposed to do next if you get an even number?
We subtract 1.
Exactly. Okay, no? Yes, Khadija, for you, it is correct. Gauri, you have answered. Yeah, that is correct. Yes, Abdullah, good. Okay. Solve the next one also, question number B and question number C from this. The options are not necessary to be there for all the values I have written there. So if you don't find the option, just write the number of images. For C, no. Shikrika, 360 divided by 180. Or the value which you are getting is, do this once again, Shikrika. For which question you are answering 8 images, Abdullah?
Sorry, sir, by mistake,
Oh,
I
okay, no, sure. No, Gauri, it is not correct for question number C. It is not correct. Khadija, for question number B, your answer is correct.
Sir, I answered the C question again. Is it correct?
Question number C, you have answered. Yeah, now it is correct. Very good. Yes, Gauri, now it is correct. Very good. If n comes out to be an even number, then you know what you have to do. If it is odd, then it has to be left as it is. By the way, is this chapter done in your school or is it not done in everyone's school? Yeah, Khadija?
In my school, it was done last term.
It was done. Okay. So in the school you were taught about this formula?
Yes, sir.
Okay, good. Khadija, you haven't answered it. Neither you, Abdullah.
Sir, right now I have the sound chapter going on, but next chapter is light.
Light is good. Light will be next. Okay. And for you guys, yeah, Abdullah, now it is correct. Good. See, basically 360 upon 180, it is 2. If n is 2, thereby we are supposed to subtract 1 from it. So thereby one image will be formed here. Okay, now basically 2 plane mirrors, you have kept it like this. So thereby only one image will be formed. Okay. Gauri, I was asking this, that you told me earlier that in your school, the sound chapter, it is not part of the syllabus, right?
Yes, sir.
Chakarika, for you also, it was not there, as you told me, or like you didn't had the update on this.
So which chapter?
Sound.
Yes, sir. It's not there in the textbook.
Okay. Abdullah, what about you?
sir, it is there.
It is there for you. And for you also, no? Khadija, for you
Yes, sir.
also. Okay. Did you guys attended all the lectures for that chapter from in the batch?
Yes, sir.
Okay.
Yes.
Abdullah, you also? Okay. Okay, let's continue further. By the way, also let me know like when the syllabus in your school is supposed to be finished, when it is going to finish. Everyone tell me when the syllabus in the school will be supposedly finished.
So for final?
Yeah, for the final syllabus, for the final exam.
Sir, for me, it's going to be finished at mid-Feb.
At mid-Feb.
Yeah.
Okay. I'm not asking about like whether the revision will continue when the I'm not asking in regard to that. Like when the whole chapter, the complete syllabus, it will be finished by the mid of Feb. You are saying in your school.
Yes.
Okay. What about you, Khadija?
Sir, it'll be done till December or January because my exams are in February.
Okay. And others? Gauri? Yes, Gauri
Maybe in February,
in
because
Feb.
we have only completed 9 chapters yet.
Okay. And for you, Chakrika?
So like which term?
For the final exam for the second term?
So right now my second term is going on.
Second term has already started. So there are 3 terms in your school.
Yes, sir.
Okay, okay. So for the third term, I suppose again it would be by the month of Feb, I think. Okay, so
Uh,
all of Mhm.
I think it's gonna be by February or March.
February or March. Okay, and all of you, I suppose you guys will be giving your final exams in the month of March, right? In the March, you will be having your final exams. Okay,
Yeah, for me, it's on end of March.
end of March. Okay, okay. See, right now in the batch so far, now this chapter which we are doing, before that, all the chapters have been done. This chapter when it will be finished now, our approach in the, like, I suppose by the first week of the November, I suppose, like 31st is going to be holiday for Deepavali. Okay, you guys would have got the notification. The classes will be resuming from the 2nd November. Okay, today we are having class, the next class will also be there. Okay, so what I was trying to say that the chapters that we have done so far in the batch, okay, so the revision classes will start. Once we'll be done with all this, the revision class will start. Getting it now? Okay, let's continue by the way. Yeah, this question we were supposed to do. Okay. Also, you guys can send your doubts to me. You can send the list of the topics or names of the chapters or any particular topic or subtopic wherever you are having difficulty. You can send your questions from the exercise, from your exercise book also. Okay, no? So you can forward it to the team. I will be getting it from them. And in each and every class, it will be discussed. Okay. To make sure you guys start to revise the chapters which you have studied from me earlier or you have studied earlier. And wherever you find difficulty, prepare a list of, like, prepare a notebook, like take a short notebook like this. And in that, from each chapter, list down the names of the topics in which you are having difficulty. Okay, no? So thereby you guys will be able to keep track of your progress. What I used to do when I was, yes, Chakrika?
I'm sorry to interrupt. So then for this question, how are the mirrors placed? Like
How are the?
mirrors placed? I don't quite get it.
No, this question is not about the multiple reflection actually. Okay, no? If you see,
Yeah.
angle of reflection is being asked here.
Yes, so like in which angle? Like how are the mirrors placed?
Right angles, at right angles, at 90 degree. Okay, no? So two mirrors A and B are placed at right angles, meaning at an angle of
In
90
front of
degree.
each other?
Mhm.
Like in front of each other, facing each other?
No, it's like this. Let me just draw a diagram for this. It is kind of like this.
Yes, sir.
A and B like this. Okay. Yeah. So earlier what we were saying that you can go through each and every chapter. Okay. And just prepare a list of the topics in which you guys are having difficulty. Okay. Okay, let's get back to the question. So two plane mirrors A and B are placed at an angle of 90 degree, right? A ray of light is incident on mirror A at an angle of 25 degree, right? So it is falling on the mirror, okay, at an angle of 25 degree. And after falling on, and as it falls on mirror A, so it will be getting reflected from the mirror A. And actually, I mistakenly draw it over here. So it is incident on this at an angle of 25 degree. And it falls on mirror B after reflection. And the angle of reflection for the ray reflected from mirror B would be what? So you have to find the angle of reflection for the mirror B. Let's see what you have answered. Okay, Gauri, you are saying this. Okay. Everyone try to solve this question.
Sir, can you explain how to do it?
Okay, I will not do the same question, but I will give an example of another question. Okay, now. So let us consider that there are two plane mirrors. Let's call this as QM, two plane mirrors again inclined at an angle of 90 degree. Let us say that there is a incident ray falling on this at an angle of 30 degree. Let us say the angle of incidence is how much? 30 degree. Okay. And as it will be falling on the mirror Q, it will be reflected back also, right? You guys can see this clearly now. So it is falling on the mirror B, and from the mirror B, it will be getting reflected back. Okay, so we are going to draw the normal line here, as we have drawn the normal here. So let's draw a normal here also. So you guys have to find, like, if in this question, same thing is being, let us say, asked that what is the angle of reflection? Angle R is equal to how much? Okay, so this we can calculate in the following manner. So you guys tell me, if the angle of incident is 30 degree, so the angle of reflection will also be
30 degree.
exactly, everyone, right now. So that will also be 30 degree. Okay, so this is now what you can do now. See, we can do a little bit of construction here. You can meet the two normal lines like this. Two normal lines can be joined together like this. So a square is formed, isn't it? Does it not look like a square? A square is formed here now. Getting it? Like this normal is perpendicular to the plane mirror. This normal is also perpendicular to the plane mirror. So they will be meeting at an angle of 90 degrees. So this is 90, 90, 90, 90. So a figure which has all the angle equal to 90 degree. Okay, so that will be basically this. So if this is 30, what will be this angle? You guys would have learned about the alternate inferior angles. Yeah. If there are two parallel rays and there's a transversal like this. So if this angle is 30, so this angle will also be 30 now.
Yes.
So what about this? Exactly. So that one is 30. So if this is 30, so thereby this one will be what? Like this angle of incidence? Will it not be 60? Because the complete angle is 90 degree now, guys. Yeah. So angle of incidence on this mirror B is 60. So angle of reflection by the first law will also be 60. I hope it should be clear to everyone. Yeah or no?
Yes, sir.
Yes,
Good.
sir.
So there
Okay.
is no 16 option.
See, I gave a different question. I told you now, like, it's
Yeah,
not
yeah,
from the same one. Okay, let's see what you guys have answered. Okay, Chakrika, you're saying this. Okay, let me go through this. Yes, that is correct, Chakrika. Yes, Abdullah, that is correct. Very good. Khadija, you understood this now? And Gauri, you also?
Yes, sir.
Okay, take your time and solve this. Okay. Meanwhile, you guys also don't sit idle. You guys answer some of the questions. So, Abdullah, you tell me if the value. You tell me the formula to find the number of images formed when two mirrors are placed at an angle. Yes.
Yes,
What is
formula to find when two plane mirrors.
are inclined at an angle? Two or more than two plane mirrors are inclined at an angle. So to find how many images will be formed, what is the formula we use?
Sir,
Hmm.
uh,
N equals to
360 by the number and theta.
basically theta. Theta is representing the angle. Okay, na? So it's 360 upon theta. Or basically, if you are having difficulty in remembering theta, so this theta is basically, yes, Khadija, your answer is correct. Very good. Yes, Gauri, it is correct. Everyone got this. So option number C is the correct one. Yeah. So this theta is basically angle between the mirrors. Okay, na? Angle between the mirrors. Okay. Chakrika, you tell me, if the value of n came out to be odd, what do we do?
So And if it's odd,
Yes, if it is odd integer,
sir, it's gonna be the same. Like
it's going to
as
be
images.
exactly. Well done. Okay. Now, before we learn about the dispersion of the light, we had to actually learn about few important things. Just 1 minute. The concept of the curved mirror that we haven't discussed in detail. Okay, so we are going to quickly learn about that, and then we'll be learning about dispersion. Okay. Curved mirrors. So you guys must have heard about the curved mirrors, like concave mirror and the convex mirror, right? So you might have seen certain devices like telescopes. Huh? Have you guys ever used a telescope to look at the moon or to look at celestial bodies? Yeah,
Yes, sir. I have.
No.
you have. That's really interesting. Okay. So what kind of mirror is used there? It's a concave mirror that is used in the telescope, or in the shaving mirror, concave mirror is used, right? What is common between telescope and shaving mirror? Both of them forms large images. Right now, both of them forms large images. So that is the concave mirror, right? Or also in certain kind of like in the like the rear view mirror that is used in the vehicle. So it forms a smaller image, plus it gives a wider field of view. Wider field of view. When you go to a shopping complex, on the corner of the shopping complex, there will be a giant piece of curved mirror installed at the corner, in which pretty much image of everything in the store in the complex will be formed. Getting it, guys? What kind of mirror I'm talking about? So that is the convex mirror. So curved mirrors are, or basically we also call them as the spherical mirror. Spherical mirror. So there are two types of spherical slash curved mirrors. So first one is the concave mirror. Another one is the convex mirror. So when you look at the surface of the concave mirror, so it will be curved inward. It is curved inward. Okay, now, and it will form a real, and it can form a virtual image also. It can form a real, and as well as it can form a virtual image also, right? So say for example, in certain kind of mirrors, in the concave mirror, if you were to keep your hand in front of the concave mirror, a really very big image of your hand will be formed in the concave mirror. Okay, now in the concave mirror, bigger images will be formed, right? So concave mirror kind of looks like this. So the reflecting surface, is it bulging outward or is it bent inward? Is it bulging outward or is it bent inward?
Bent inward.
Right. So this is
That
the exactly. So that is the reflecting surface, which is bent inward or basically curved inward. So that is the case of the concave mirror. Okay. Plus at the back, will it be transparent or will it be opaque?
Opaque.
Right now. So that is an opaque object over here. So that is the back of the concave mirror here. Okay. Now see what happens here. When the rays will be falling on the concave mirror, now when the rays will be falling on the concave mirror, so it will converge at a point. It will be converging at a point, and the image will be forming in front of the concave mirror. This is something which we'll be learning in detail in the next classes. We'll be learning about that in detail. As of now, I'm going to tell you about the general things about the concave mirror, right? So as the rays will be passing on this one, as the rays are falling on this, so all of them will reflect from it, and all of them will be meeting at a point like this. Let me just erase the third one actually. Okay. Now let us learn about some of the important characteristics of this concave mirror. Okay, now this mirror is bent inward, plus um, plus the image size formed in the concave mirror will be bigger than the size of the object. So bigger size image is formed. It is formed. Further reflecting surface is bent inward, and the examples where it will be used are as follows. You guys tell me, moments ago we have learned about this, like where it will be used. Yes, remember about this? It will be used in the shaving mirror, right? Or in the telescopes. So it is used in telescopes and in shaving mirror. Hope that much should be clear about the concave mirror. If there's any question in this, please let me know. Yes, Khadija, Chakrika, Abdullah, anyone? Khadija is not here. Talking about the convex mirror, so the reflecting surface will be bent outward. It will be bulging outward. So it will be kind of like this. So the reflecting surface is bulging outward in this. Okay. So what will happen here? Let us say that these are the rays of light that are falling on this. These rays of light is falling on this, and we will extend it backward. Let's say we are extending it backward, and from there it will appear to be diverging actually. So as the rays of light will be falling on this, it will get diverge into different directions, like you guys can see here. It is diverging into different directions. So that is how the reflection of light will be taking place from the convex mirror. The rays will be diverging. But in the case of the concave mirror, the rays are converging at a point. Converging means to meet at a point. But in the case of the convex mirror, what is happening? The rays are, yes, the rays are diverging now.
Yes, sir.
Okay. Talking about the nature of the images, like nature of the image, so image formed in this will be smaller as compared to the size of the object. So it forms a small image, but it covers a wide range of area. It gives a wide field of view. Okay. Some of the important characteristics are as follows. Image formed is smaller in the convex mirror. Another thing is that reflecting surface is bulging outward. Further, examples of instruments in which it will be used, like it will be used as a security mirror. It could be installed in the ATMs or in the shopping complexes where it can be installed. So used as safety mirrors or in rear view mirrors. Rear view mirrors of the vehicle, so there it will be used. So these are some of the common uses of this. Okay, now these are some of the common uses of this. So hope that much should be clear. I'll be putting the screenshots and then we'll be continuing with the topic of refraction and dispersion in the next class. Anyone has any questions, please let me know. Yes, anyone have got questions?
No, sir.
Okay, you just stay in the meeting. I'm dropping the screenshots. And I suppose everyone is preparing the notes also,
Yes, sir.
because if you're not, I will be asking you guys to show the notes, okay?